on this computer. So good morning all. Properly, we're going to go into equations of motion. Equations of motion tell us how we can calculate our quantities of motion, which will be speed, being velocity, acceleration, time, and distance. Okay, so it's a lot more precise than the graphs, very much more precise than the graphs, and it does involve some mathematics, and this is what we call applied maths. This is the part that students get problems with physics because they're applying what they're seeing in a question to equations. But I'm going to show you how to do it. It's not very hard. It just takes some practice. So reading from the screen, we can determine, let me just get my pen back up. All right, we can determine any value of motion in a straight line or equations of motions is in the topic of kinematics. Kinematics basically looks at motion in a straight line because that's how vector quantities move. They move from one point to another in one straight line. We don't look at curves and all kind of weird parts. We just look at straight lines. So we'll determine any value of motion in a straight line with the use of equations alone. 4 equations have been derived to do this, and these equations we use 5 symbols. These 5 symbols are 5 quantities. All right, so we have 2 symbols for velocity. All right, we have a U and a V, U representing initial velocity or first velocity, because we know when something is moving, it's going to start off at some speed. That one of those speeds could be at rest or could be 0, and then it's going to speed up and reach a next speed. Or it could be traveling at a given speed, then start to slow down and reach another one. So we always have 2 velocities to consider. We have the initial velocity, which is our first velocity, and then we have V, our final velocity. Now, why do we have U and V? The explanation is really, really simple. V, we know, stands for velocity. And why they have the U? Because U is before V in the alphabet. We just say, let's use V as the initial part or the first velocity and V as the final velocity. It's simple as that. It was just where it was in the alphabet. No kind of weird symbol from the Greek letters or Latin words. It's just where it was in the alphabet. Okay, so we have acceleration is common A. All our letters here are common. Nothing here is capital. Time is T, and displacement or your distance is in a S. So what are our 4 equations of motion? I have them labeled in the order that we usually see them. We have equation 1 of V is equal to U. V is your final velocity. U is your initial or your first velocity, plus acceleration multiplied by time. Okay, so simply it's just one number plus 2 numbers added to each other. Really, really simple maths. There's no sort of complicated maths here. The hardest thing, honestly, is for students to allocate their numbers correctly. But that's what we're going to do here today. We're going to figure it out and learn how to do it properly. Equation 2, we have distance or displacement is equal to initial velocity by time plus a half multiplied by acceleration multiplied by t squared. It's only this t that is getting squared. You're not squaring the whole term. Second one, also to work out distance, it is half t by u plus v. We just did equation velocity times graph. Does this equation look familiar? From the velocity time graph, does that look familiar? Did we use that equation?
Yeah, miss, the area to find a trapezium.
And the area of a trapezium, what did we find with the area of a trapezium in velocity time graph?
The acceleration was
No.
the velocity was
Total,
sorry.
No.
the total the
The
total
total distance
distance.
traveled. Thank you. Very good, Malaika. Right? So here you can't see how one relates to the other. This is the exact same thing. We have half by one value plus multiplied by the sum of other values. So our um, equation of motion and velocity time graphs are connected in some form or fashion, but it's easier where you just have to add numbers, subtract, or multiply. And our last equation is v squared is equal to u squared plus 2 by a by s. Now, sometimes we are going to have zeros in here, so it's going to make life very, very easy. Okay, so we have our four equations. We label them as equations 1, 2, 3, and 4. So when you're doing questions, you're just going to say use an equation 1, use an equation 2, even though it's not really necessary because people have labeled them differently. That's fine. Now, there are some notes and some guidelines in reading and using these equations. So let's go through and read what we have on the screen. Tips when using these equations. Now, these are tips I have come up with and you use when you are doing your questions. When we have a body starting from rest, what does rest mean? Rest means not moving. It's just there, sitting down on the ground, parked up on the ground or whatever, right? So once something starts at rest, that means that its first velocity or its initial velocity is 0, because when something is not moving, its velocity is 0. So anytime you read a question, they usually hide values inside of the question. So we have to learn to look at our questions and pull out, or as I say, mine our values from the questions. Hold on for a sec, y'all. All right. So I'm back. The next one we have here, v is equal to 0 when a body comes to a rest or a stop. When it comes to a rest or stop, that means it was traveling and then it comes to a stop. Okay, so comes to a stop or rest means that it has stopped moving, it has decelerated, and is now stationary. So your final velocity is 0. Acceleration is accelerating. Please note your words. Accelerating is not the same thing as acceleration. Acceleration tells us what the value of A is, or that is your acceleration value. When we say a body is accelerating, right, this means that let's use our proper words, our velocity is changing. Who's my fire? Hold on. Just now. Okay. Let me find out. I don't want people just joining my room randomly. You all know who is joining on as my fire?
No, miss.
Okay. If any of your classmates tell you they're trying to get in, let them identify themselves properly, please. Right, so accelerating, when we see the word accelerating, that just means that the velocity is changing. All right, and this indicates that we are going to have a u and a v being stated. Don't worry, when we're doing questions, you will see it, you will encounter it. All right, anytime you see accelerating, that means that we are looking at changes in velocity. The values you see there will not be the acceleration. Okay, moving on. For when an object is slowing down, it is decelerating. Decelerating means that it is slowing down, and we went through that already. Deceleration is a negative acceleration. So that's simply, anytime we have to work out a deceleration or we encounter negative acceleration, simply means that the body is slowing down. Please, please, please follow the rules of BODMAS all the time. So you work out multiplications first. You work out stuff in brackets first, and then you add and multiply to other things. Please don't just walk through and add and multiply straight across. You all should know how to use BODMAS by now. And last and not least, well, we'll encounter some more tips. Use SI units at all times. SI units meaning you have to use your distance in meters. And you know I'm going to give you distance in kilometers. You have to use time in seconds. Sometime you get your time in minutes. So you all have to be very careful. Please, please, please use the right SI unit. That's what we're here for you to get guidance in the subject, and we can just move forward. So let's look at our first question. Our first question is really simple. All right, I think it looks a bit small. Let me just get it a little larger. Right, so example, a car starts from rest and uniformly accelerates for 1 minute over a distance of 1 kilometer. Calculate its final velocity and acceleration. Now, I see only two one number values in there, and they ask us to find a whole bunch of stuff. But this question is loaded with information for us to use. So let's learn to go through what this question is actually trying to tell us. All right, so let's look at different parts of the question to start with. A car starts from rest. I know starts from rest means, if you go back to your notes, starts from rest means that the initial velocity is 0. Anytime you do these questions, write down UVATS. This is why students have come up with the term or the other way of calling out equation of motion as UVATs. Students have come up with this, so they say UVATs means we use an equation of motion because you're looking at U, V, A, T, and S. Always write down those 5 letters at the start of your question, and then you start putting numbers with those letters. Trust me, it helps. So a car starts from rest and uniformly accelerates. Accelerates is not acceleration, so we do not know what the acceleration is. For 1 minute, 1 minute is time, and I know that 1 minute is equal to 60 seconds. So my time will be 60 seconds over a distance of 1 kilometer. Kilometer is your distance, and 1 kilometer is 1,000 meters, because I did say we have to use SI units for this to work every single time. So we have 1,000, and they have asked you to find the final velocity and the acceleration in your question. Let's go through again how to mine your question for your values. You see how we get a whole bunch of values from your question? So a car starts from rest. Starts from rest means that the initial velocity is 0. Okay, that's from the notes. It accelerates. Accelerates means it is speeding up. They did not tell us our acceleration. Those are 2 different words. For 1 minute, and 1 minute is going to tell us our time over a distance of 1 kilometer, and that's going to tell us our distance. All right, everyone? And they have asked us to find V and to find A. So let's go ahead and find V and A. All right, starting early, like you're going to say, but miss, which equation? All those equations. All right, there's a way to do this nice and simply without getting a headache. All right, let's clear the board. I want to find the final velocity first. All right, so we're not looking at acceleration right now. What I usually tell you all is just to, let's just cover this. We don't want to look at the A's yet. What equation in your equations of motion has U, V, T, and S? Equations 1, Let me see if I can get it in the screen. Equations 1, 2, 3, or 4. Which one has only U, V, T, and S? Anybody?
Number 3.
Equation 3.
Number 3. So what we're going to do, we're going to plug in our values. We're going to realize that now equation 3 is what's going to help us here. Right? So using, right, equation 3. So we're going to have S is equal to half by T by U plus V. I know what S is, I know what T is, I know what U is, and I could just find V. So it's going to be simple algebra, simple algebra. Let's plug in our values. S is 1,000 equal to half by 60 multiplied by 0 because your initial velocity is 0 plus V. And we know anything that adds to 0 is the same number. If I take $10 and I add $0, I still have $10. Okay? So let's just work out and simplify. So I'm going to end up with 1,000. Half of 60 is 30. 0 plus V is V. I think that's a really easy equation to work with right now. All right, so that's to make life simpler. I always put the letters on one side, on our left-hand side. So 30V is equal to 1,000. How do I find V, y'all? Anybody?
We V equal to 1,000
Over 30.
multiplied by 50.
Divide.
Divide.
You would now get me a little worried. Oh, let's get into the silliness you say sometimes. So we know to get rid of the coefficient of a term, all we have to do is divide both sides by that number. So it's going to be 1,000 divided by 30, which will give us 33.3 meters per second. Yeah, 33.3 meters per second. Get your calculators out. Remember, calculators are allowed for every single physics question you'll ever do in your life. All right, so if you want to write that down, go ahead and write it down. All right, I'm just pulling this back down for you all to see. So the next part of the question asks us, what is the acceleration? Now I have 4 values out of my 5. I have U, I have V, I have T, and I have S, and I want to find A. So how do I find that? Let's look. Always, always, always keep it simple. All right? The KISS method works in life. All right, you all should know as the KISS method. Keep it simple, stupid. Because sometimes we do stupid things by trying to make things too complicated. All right, so we're going to keep it simple. Which is the simplest equations out of all of these that has A in it? 1, 2, 3, or 4? Equation 1. All right, so we're going to use equation 1. V is equal to U plus AT. We know what U is, we know what V is, we know what T is. So let's put in our values. We're going to get 33.33 equal to 0 plus t is 60, 60a. You know, anything that is added to 0 is the same number. So we're going to have 33.33 is equal to 60a. A will be 33.33 divided by 60, and that's going to give us 0.56. You all got that? Meters per second squared. Try to the calculators. Remember to get rid of the 60. You divide both sides by 60. Anytime you want to get rid of the coefficient in front of a letter, all you have to do is divide both sides by the number. All right, anybody got that when they tried it?
Yeah, miss.
Good. All right, so let's try a question. I'm going to start you all off on the question, and then you're going to go ahead and try it on your own. All right, so I'm going to help you out. Hold your hand, as they say. So I have question 1. If you look, the handout does have quite a few questions for you all to do. So I'm going to put that up, how to do the solutions, you know, in the Google Classroom for you to submit those, but you're going to get that probably later on after the PD has been submitted. All right, so we have question 1. An airplane accelerates down the runway at 3 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. All right, so we have here, you're going to the very first thing you do is write down your UVATs. And now you're going to start putting in numbers and see what they're asking for you. Okay, so a plane accelerates down the runway. Accelerates here does not mean acceleration. Okay, that means it has started from rest. All right, because a plane will start from rest. If you, for those of you who have been on a plane, it will go to the end of the runway, right? And then just like a car, the pilot hits the accelerator. There is an accelerator. There is a pedal to hit for acceleration in a plane, just like a car, right? Well, it's usually a handle that you go forward with. All right, the brakes as they hit with the ground, so they move the lever forward, starts from rest, and it starts to move forward. They do not know what the final velocity is. It accelerates at, now here they did tell us the acceleration, at 3.2 meters per second squared. Remember, acceleration is meters per second squared, and velocity is meters per second. So there is a difference in the two. Please note your units. Your units tell you and guide you where you're going. So it has an acceleration of 3.2 meters per second squared for 32.8 seconds. 32.8 seconds is your time. 32.8 seconds. And they have asked us to determine the distance traveled before takeoff. So they want to know what is S. So to make life easy, as I always tell all my students, all they're going to do is block off what you're not using. We know what U is, we know what A is, we know what T is, and we've been asked to find S. So that means they don't want anything to do with V. All they just do is just block off V. Don't erase it, just block off the V. So what equation out of our 4 equations has S, T, A, and U in it? Equation 1, 2, 3, or 4?
Equation 2.
Equation 2. All right, so we're going to use equation 2. All right, so you're going to use equation 2, which is S is equal to UT plus a half AT squared. And this is going to be simple to work out because 0, U is 0 multiplied by 32.8 plus a half multiplied by what's our acceleration? 33.2 multiplied by our time squared, which is 32.8 squared. So we go and work that out. 0 by any number is 0, so we take that out of the equation. And we're going to just multiply these straight across, and you all tell me what you get. Work out those numbers and tell me what you get all. So when we calculate this out, you all are going to get 1,721.
Yeah.
21 meters. And that is about right, because if you look, runways are usually, for big planes, are usually about 2 or 3 kilometers. Right? That's why they require a large space for airports, because you need to travel quite a distance before especially your big planes can take off. The small planes could take off on just a small strip of road, right? If we cleared out the backfield, right, behind Northeastern, a small plane can land there because there's enough space. The whole backfield, not just Northeastern section, government sector. All right, so you all want to try a question on your own? Let's try number 2 on your own. Let me just make it bigger for you to see, even though you should have the handout in front of you. All right, so give it a try. So we have question 2, where a car accelerates from rest and it starts from rest and accelerates uniformly over a time of 5.21 seconds over a distance of 110 meters. Determine the acceleration of the car. So as I said, the first thing you do is write down your UVATs. You see, even I use the term UVATs. And you start putting numbers. Okay, so let's read our question. Starts from rest. Oh, that was a horrible straight line. It starts from rest. And this indicates that U is 0. It accelerates uniformly over a time of 5.21 seconds over a distance of 110. And they have asked us to find the acceleration. So that means we don't want anything to do with V. So all I just do is just take out the V. So if we look here, we use equation 2 again. So you're going to have S is equal to UT plus a half AT squared. Let's get rid of this to give us space. All right, so let's start pointing out numbers. 110 is equal to 0 by 5.21 plus a half multiplied by A multiplied by 5.21 squared. So you're going to get 110 equal to, this entire term works out to 0, and anything that's added to 0 is the same thing. So we don't need to go through all that trouble. 5.21 squared is 27.11 divided by 2. All right, so that's to give us some more working space. Hold on. 27.11 divided by 2 will be 110 is 13.57. Who is writing? Michelle, you just wrote on my screen, sweetie. Take it off. Thank you. multiplied by A. All you have to do is divide both sides by the 13.7. And you get 8.10 meters per second squared. Now, if you all got a different decimal, it's just how much you rounded off. I use the exact value by itself. You all got that?
Miss, I get 8.11.
Miss, I get 8.110.
I get 8.11.